To make light in the middle of the rainforest alone with nothing but gravity. This is awesome. I'm gonna have to put this head strap camera on because I don't have enough hands, but check this out. So there you go. I'm in the middle of the rainforest powering a light with nothing but gravity. He had visited Kenya where he had met people who had to use kerosene lamps at night so their children could do their homework. Children can get burned, the soot causes respiratory problems, you've got to pay for the kerosene, and think about it, you're burning an open container of fuel inside your house. It's a fire hazard. One side of the mechanism is closest to the weight, so the forces are larger. Jim uses internal gearing here to distribute that load across more teeth. The further through the drivetrain you go, the fewer the teeth you have to engage because the torque gets lighter and lighter as the speed runs faster. Eventually, they're even light enough so that the generator can run with just a small rubber band, which has the added bonus of being quiet at high speed.
As you can see, the Gravity Light has an ingenious design and extremely compact. However, it would be extremely difficult for someone in the field to fix it without any engineering background, and the price is around $80, and ours was built for about $35. So we followed a practical approach for building all these things. Here in Design 1, it shows a chain and gear system being used to turn a light due to a dropping mass. However, the problem with this is the mass has to fall at an astronomical rate for the system to actually turn and make the light illuminate. The second design is a ball screw linear actuator used to turn a DC motor and create the light. However, this mechanism would have cost more than the Gravity Light currently does. Finally, a pulley system, which became our final design, was used. The power is generated through two wheels relying solely on friction to get the generator to spin. But the main draw of this one is the pulley that creates a 5-to-1 ratio of the mass falling compared to the rope speed. So the rope comes out of the spindle 5 times faster than the mass actually drops, which increases the time the mass is in the air and increases the time the light is actually illuminated. So for our final design, we combined the pulley system and Design 1 due to the pulley system's biggest problem being with relying solely on friction, so we added that Design 1 input of a belt and sheaves. Now here you can see our alpha prototype, which was more modeled after Gear 1, trying to prove that we could use this system between a belt and sheaves. While unsuccessful, we did learn that it would be feasible for our final design. Here, I was testing the pulley system and if we could actually drop it using a mass that is not ridiculously high, which was successful. So for the final design,